For this explainer, I want you to start by just imagining something with me, if you will. Picture a world where the air is noticeably purer than ours. The oceans, they're vastly deeper, incredibly wider. The climate is infinitely more stable. It's a place where life itself actually thrives even better than it does right here on Earth.
For centuries, we humans have held on to this really comforting belief that Earth is the ultimate, absolute, perfect sanctuary for life in the cosmos. I mean, it's all we know, right? But modern science is bringing a truly shocking possibility to the table. What if Earth actually isn't the universe's perfect planet? What if, out there in the vast dark, there's a world that is literally better?
Section 1. Is Earth perfect? Our flawed sanctuary.
So, we naturally tend to think Earth is perfect simply because, well, it's our home. We were born here, but if we look strictly through a scientific lens, our ultimate sanctuary actually has some massive design flaws. Earth's history is incredibly violent. We're talking massive asteroid impacts, dangerous supervolcanoes, brutal ice ages, and these recurring mass extinctions. Take the Great Dying about 250 million years ago. That event wiped out nearly 90% of all species. And of course, we all know exactly what happened to the dinosaurs 66 million years ago. So the crucial point we have to ask is, if Earth is the most perfect planet possible, why has life faced total annihilation so many times? This exact question forced scientists to completely shift their perspective.
Section 2. The Superhabitable Planet Theory, proposed in 2014.
Back in 2014, scientists asked a groundbreaking question. What if we could actually upgrade Earth? To figure that out, we have to look at the baseline. Earth's habitability relies on a few key things, right? Liquid water, a relatively stable temperature, oxygen, a protective magnetic field, and being at an optimal distance from our sun. But what happens if we make every single one of these factors just slightly better? That's where the science gets incredibly fascinating.
Section 3. Conditions of an ideal planet. The ultimate blueprint.
First up, size. Surprisingly, an ideal planet isn't Earth-sized. It's actually about 10% larger. A slightly larger planet has more mass, which means it retains its internal heat for much, much longer. And that internal heat is an absolute game changer. It drives the tectonic and volcanic activity that's essential for recycling minerals and maintaining a highly stable atmosphere over billions of years. And speaking of billions of years, 2 billion years! Earth is about 4.5 billion years old, but scientists believe an ideal superhabitable planet would be older, between 5 and 8 billion years old. Remember, it took Earth billions of years just to form complex life. Imagine if evolution had a 2 billion year head start. Just think about how incredibly advanced life could become with all that extra time on the clock.
Of course, a planet is really only as good as its star. Our sun is stable enough, with a lifespan of about 10 billion years. But orange dwarf stars, also known as K-type stars, they are a whole different ballgame. They can burn steadily for 15 to 30 billion years. They are highly stable and emit very low levels of dangerous radiation, especially compared to those volatile red dwarfs, providing the ultimate long-lasting safe harbor for life to just thrive.
So what does the surface of this perfectly aged, perfectly sized planet actually look like? Well, it wouldn't just be deep, empty oceans. We'd likely see endless wetlands, massive lush forests, and sprawling shallow oceans. On Earth, the highest levels of biodiversity are found right along our coastlines in shallow waters. So a planet dominated by sprawling shallow oceans? That would generate a massive explosion of biodiversity, allowing life to spread and adapt incredibly fast.
Section 4. Major superhabitable candidates. Real exoplanet worlds.
So you're probably wondering, do places like this actually exist? The answer is a resounding maybe. Our first major candidate is Kepler 442b. Situated about 1,200 light-years away, this exoplanet sits perfectly within its star's habitable zone, meaning liquid water is totally possible. Plus, it's slightly larger than Earth. This combination of an ideal location and a slightly larger mass makes it one of the absolute most promising candidates for long-term stability. In fact, some scientists argue it could actually be more habitable than Earth right now.
Another prime suspect on our list is TOI 700d. Discovered by NASA's TESS mission, this is another habitable zone planet. But what really makes it special is its neighborhood. It orbits a notably calm and quiet star system. We just talked about how crucial stable stars are, right? With a quiet star overhead, TOI 700d could host oceans, clouds, and a remarkably stable climate. It offers a prime environment for life to thrive, completely undisturbed by solar violence.
But then,
We have K2-18b. This is the one that really captured the world's attention recently. We aren't just guessing about its size or orbit anymore. Thanks to the totally unprecedented capabilities of the James Webb Space Telescope, scientists were actually able to peek into its atmosphere. And what they detected there were molecules that, at least here on Earth, are strongly linked to biological activity.
Specifically, they found hints of this particular gas, dimethyl sulfide. Now, why does that matter? Because on Earth, dimethyl sulfide is almost exclusively produced by life, specifically by marine life in our oceans. Finding traces of this gas heavily implies the potential for biological activity on K2-18b. While it's not absolute 100% proof just yet, it is literally the very first time humanity has detected potential biological signatures on another world. It is a massive milestone for us.
Section 5, Our Search and Future, Finding Invisible Worlds. So, how exactly are we pulling off these cosmic detective missions? Well, the primary technique is an incredibly elegant system called the transit method. Here's how it works. Step 1. A planet passes directly in front of its host star from our telescope's point of view. Step 2. As it passes, it blocks a tiny fraction of the star's light, causing a slight dip in brightness. Step 3. Our advanced telescopes detect that minuscule change. By measuring that tiny dip, we can determine the planet's size, its orbit, and, as we saw with K2-18b, we can even analyze the starlight filtering through its atmosphere to see exactly what gases are hiding in there. We aren't just finding dots in the sky anymore. We're starting to deeply understand these worlds.
But we do have to acknowledge the harsh reality here. Even if we confirm a superhabitable paradise tomorrow, the travel barrier is immense. We are talking about distances spanning hundreds to thousands of light years. With today's technology, a trip would take tens of thousands of years. Just to ever reach them, humanity is going to need to develop some radical advancements. We're talking revolutionary propulsion technology, perhaps suspended animation, or even the creation of massive generation ships, where multiple generations of humans live out their entire lives in transit just to get there.
Yet despite those vast distances, the mere fact that we're finding these worlds at all fundamentally shifts our perspective of the cosmos. It confirms a really profound thought. Earth cannot be the only one. Right now, yes, Earth is the only place we have confirmed life, but the science is pointing us toward a reality where our planet isn't the absolute peak of habitability. It's just one example of what's possible.
Which leaves us with a truly staggering thought to end on today. If these superhabitable planets really do exist out there, planets that are older, greener, more stable, and structurally more perfect for life than our own, then who is already living there? Could there be civilizations out there millions of years more advanced than us, wandering through vast alien forests and unnamed oceans as we speak? The search for these superhabitable worlds isn't just about finding a new home for humanity. It's about finding our true place in the universe. Thank you for joining me for this explainer, and as always, keep looking up.